Hi everyone, Mr. Rising here again. This lecture is all about point-slope form. So we're in the middle of talking about linear equations, and there are different forms of linear equations that are all really the same thing. You could have graphs which show linear relationships, you have tables that show linear relationships, and again, equations are another form of linear relationships. If you're following along with the Holt-McDougall book, it's Chapter 8, Section 4. Also known as the point-slope form. And the idea here in point-slope form is it passes through a point. The equation passes through a point, and that point has an x-coordinate and a y-coordinate. And the form of that equation goes like this. Y minus y1, which is the point on the line, equals m, which is the slope, x minus x1, or the x-coordinate of the point on the line. So what the heck does this have to do with anything? Well, let's just compare it for just a moment to these other forms of equations. So we've talked in the past about standard form, ax plus by equals c, where a, b, and c are values. And in all of these examples, x without the little subscript represents an input or some kind of independent variable. And y, this y right here, represents a dependent or an output. So something depends on an input, or there's this relationship going on between two things. X is the input, y is the output. x1 is a point on that line, y1 is an output, a point on that line. So a couple of quick examples here. Again, I'm going to leave this point-slope form up at the top, and it says, use point-slope form of each equation to identify a point the line passes through and the slope of the line. So I want to first look at this middle example number 2 because it's really the most straightforward. I'm going to scroll down here, and first I want to break this out for just a second because you'll notice it is y minus y1 equals m parentheses x minus x1. So it's always y minus y1 and x minus x1. So I'm breaking it down here to say, wait a minute, what I'm doing is y minus a positive 8 equals 7, x minus a positive 14. And therefore, my slope is 7, just like up here. And then the point is, oh, the x1 is 14, the y1 is 8. Now notice how it's different in this example. Again, I want to rewrite my equation just to make it really clear that I'm always subtracting. So it's y minus 2, positive 2, equals negative 3, x minus negative 6. And here's why. It looks backwards. When you look at this equation, what we're really doing is subtracting a negative 6, which is why it looks positive. So now when you answer the question, what is the slope? Well, the slope is still the value in front of the parentheses, negative 3. But now I know that the x1 is negative 6 and the y1 is positive 2. Now take a look at this third example over here. Again, it says y plus 3.7, but really the form is y minus something and x minus something. So when I rewrite this, what I'm really saying is y minus, well, if I get a positive, this has to be a negative. Y minus negative 3.7 equals 3.2 times the quantity x minus a positive 1.7. And that leads you to a slope of 3.2 positive and x-coordinate 1.7, y-coordinate negative 3.7. Feel free to pause the video right now. Please get these examples in your notes. It's really important because, again, the form is always y minus or x minus, but when values look positive, like in this example here and this example here, that actually means the point values are negative. When you're ready, go on to the next slide. Boom! I'm ready. It's time to go on to the next slide. Again, I'm going to leave my point-slope form up on the top corner and just give you a couple of other examples. The instructions here say, write the point-slope form of the equation with a given slope that passes through the indicated point. So it's now saying, hey, I'll give you the slope and I'll give you a point. You write the equation. All right. Step 1, write the form. Notice y minus x minus. Step 2, plug it in. In the first, in the first example, the x-coordinate is 0, the y-coordinate is 6. That means the 0 goes in here, the 6 goes in here. So I've got y minus 6 equals 5 times the quantity x minus 0. And then I can simplify it out. If I distribute the 5 times x is 5x, 5 times 0 or negative 0 is 0. It goes away. So this equation simplifies out to y minus 6 equals 5x. On this side, the same first step is true. Step 1, write out the form of the equation, point slope form. Step 2, substitute the values. The negative 8 is the slope. x1, the coordinate, the x-coordinate of the point on the line is negative 11. That's going to go in here. And then 7 is the y-coordinate. It's going to go right in there. Again, the key is to make the sound effect. Finally, you got to simplify it. So again, y minus 7 equals negative 8. And then x minus a negative 11 really means x plus 11. Again, feel free to pause for a minute. You need to get these examples down. For those of you who are thinking that you really want to get this, you have higher aspirations than 8th grade or 7th grade or 6th grade, taking notes is a really good idea. I'll pause and I'll go on to the next slide when I'm ready. Bam! I'm ready. Final example here I want to show you. Actually, not final example. I'm going to do 2 more. Real life example. A basement filled with water from a rainstorm is drained at a rate of 10.5 liters per minute. After 40 minutes, there's still 840 liters of water remaining. Write an equation of a line in point slope form that models the situation. That's part 1. Part 2, how long does it take to drain the basement? Well, the first thing you have to say is, wait a minute, what's the slope and what's the point? Well, the slope means you're removing 10.1 or 10.5 liters per minute. So you can think of that as a negative 10.5 per divided by 1 minute. Number 2, what's the point on the line? Well, after 40 minutes is independent, that's an x variable, there's 840 liters of water remaining. Output, that's a y variable. Set up my form, point slope form, and substitute away. And here you go, I've got an equation built. I have completed part 1, write an equation. Way to go, us. High five. Sweet. The next part of it says, how long does it take to drain the basement? And this definitely involves some algebra. So once I've got my equation figured out, let's work our way through it. And if I wanted to drain the basement, what I'm really saying is I want 0 water in the basement. 0. The water is the y variable. The amount of time it will take is the x variable. Here's what I'm talking about. What I'm going to do is I'm going to substitute 0 for this y, because what I'm trying to figure out is how long it will take to have 0 water in the basement. At this point, I now have one variable. I have x. I can solve this equation for x, and that will tell me the amount of time it will take to have no water left in the basement. How do I do that? Don't forget, it's algebra. Step number 1, simplify the equation. I've got negative 840, 0 minus 840, equals, what I've done here is I've distributed the negative 10.5 to both the x and to the negative 40. And when I do that, I get negative 10.5x, negative times a negative is a positive, plus 420. Next step after that, I'm going to subtract 420 from both sides. Simplify again. I get negative 1,260 is equal to negative 10.5x. Now I divide both sides by negative 10.5, which leaves me with an x of 120. So what that means is, after 120 minutes, I have 0 water left in my basement. Last thing I need to show you, oh my gosh, we're going up to 10 minutes, it's taking a while. When you want to convert an equation from point slope to slope intercept, here's how you do it. Step number 1, I have an equation, and this is one we figured out from before. Step So you have your equation. Step 1, distribute the slope, which means to multiply negative 8 by x and negative 8 by 11. I heard some of you just shouting out, Mr. Risen, come on, draw arrows, do it. Boom. Now I'm doing this left-handed with a mouse. It's kind of hard. That's pretty ugly. Maybe I should do it right-handed, but hey, whatever. I think you get the idea. If you don't, get over it. Here's what it looks like. Y minus 7 equals negative 8x minus 88. Step 2, solve for y, which means get y by itself. So I need to add 7 to both sides. And step 3, simplify. Now I've got y equals negative 8x plus 80 or minus 81. Now if I could just straight up graph that if I wanted to, but I need you to know how to do that. Okay, this video took a little bit longer than I expected. My apologies, but I know it was really worth your 10 minutes and 53 seconds.